Hello everyone and welcome to another AP Computer Science video. This video is going to focus on one topic, primarily the use of the this keyword in the Java programming language. The this keyword has several uses and we'll see them today in this example. And the goal is to be comfortable with its usage in these different ways. Two of the ways are important for the AP exam. The third way is a useful tool to have, and it's not necessarily required that you know all the details, but we'll see these different usages and we can decide how comfortable we are, and if you have questions you can ask them and learn more about this keyword. It is a helpful tool. Its primary goal is not one of necessity. You don't have to use this keyword almost ever, but there are scenarios where it makes the readability of your code better. And that's an important thing because writing code is not just about solving a particular problem, but it's solving it in a way that is flexible and robust and can be improved upon by other human beings, either yourself as a programmer or other programmers that might come along and use your code. And if we want to take advantage of what the language has to offer, we have to be comfortable with the different tools. And this keyword is one of them that can make your code a little bit easier to read. And it is also a matter of style. Some things are purely a style choice, and you can make that decision, but you should be aware of it to be comfortable. And at the end of the day, you will see it used in some fashion in the AP exam, and you should know what it means. And if there is a very small situation where you are required to use it, then you should know when that happens. So that's the goal of this video. So as an example, what we're going to do is we're going to kind of write a class that represents what we're going to call a security bot. It's kind of like a robot that maybe exists in the future. It kind of roams a particular area and has responsibilities to secure the area, either by monitoring them and sending signals, or maybe defending an area, or sounding an alarm, something like that. And so we'll read some details that I've written up that represent a security bot. Security bot has a numeric security level representing its responsibilities. The higher the number, the more work and security it must provide. So a bigger number will be a more secure or more important robot. Different events may lower the security level of a security bot. So it's possible that the security level goes down or potentially up in different ways based on things that happen to it. Security bots may also be active or inactive. So it might be at some point that we may have a security bot object that exists in our system and we have to turn it off, turn it not to be active, or turn one on so that it is active. And then we also say security bots may check the security of other bots. So if the check bot is below some minimum security level, then it's deactivated. So it's possible that one security bot will have to decide, is this other security bot safe, and should we turn it off or turn it on, right? And there will be some minimum that's described. So this is just kind of a rough idea of what our class is going to do, and we'll fill in some details as we go. Typically, I like to, once we have our class, do instance variables, the data that's going to represent this thing, and then maybe constructors and how we might want to allow someone to build one of these objects in RAM in our computer system. And then finally, methods that are useful that may do things. And we're going to use the this keyword in all three of these scenarios. So the first thing I want to do is make some instance variables, and we'll just kind of stick with the two, and we might also have to make a static variable to represent that minimum. So these are kind of three useful scenarios. First, we should remember that instance variables are always private when it comes to the AP exam. There's very rarely a scenario where you wouldn't make them private. It's a Java standard, and so we're going to follow it because we are taking the exam and we should be comfortable with that idea. So we'll say private. And we have one called security level, so let's go ahead and make it an integer, and we'll say security. I'm going to be wordy on purpose. Security level. Maybe a boolean to represent whether it's active or not, because we need to know if the bot is active or not. So boolean active. And then the last thing that I mentioned, we might add more, but for now we'll stick with these two things. But I mentioned there's some minimum security level that we have to kind of be aware of. And so maybe making a private static variable, because we want all security bots to be aware of the minimum. And there's no reason to make a copy of the same number or even allow them to have a different number. If one bot says the minimum is 5, then all bots should use the minimum of 5. So that way it's kind of an agreed upon thing. It is shared, and remember the static keyword makes variables shared across all objects of the same type. So immediately all security bots will see the same variable. And so this is kind of the opposite of an instance variable. Instance variables, every object has their own copy. So one robot has its own level and another one has another level, but the minimum will be shared across all of them. So there's one minimum. If one person sees it, they all see it. If one person changes it, they all see the change. So let's go and do that. We'll say private static, and we'll make it an int, and we'll say minimum. We'll call it min level. Right? And again, I also mentioned in our previous examples when we did static, that this is kind of the one-time scenario where it's pretty much okay to initialize the variable outside of a constructor. Since it's not an individual object that's going to determine the value, we can just say all of them see this value. So we can do something like, I don't know, 3. So I guess in our system, 3 is a pretty low number, and so if the security bot's level is below that number, it's not secure, so we should deactivate it in some fashion. That's what our notes might mention. So now we should make a constructor. I want to make a constructor that fills in the security level and whether it's active or not. So we can say initially, oh, your level is, whatever, and you are active or not, whatever values are passed in. So I would say pause the video, give yourself a minute if you're following along, and write a constructor that accepts the security level and whether it's active or not, and saves it in the instance variables. And then I will, when you continue the video, do the same. Okay, so if you've done this, we can see hopefully that it's a pretty standard situation. Our access modifier is public because we want someone to be able to construct our object. Remember, when we design a class, when we make constructors and variables, we're not using this thing yet. We're making the blueprint. We're writing the blueprint so that in the future, maybe someone else can use the security bot. In our case, we will be that other people. We will maybe make a tester to prove that it works. But the idea is that our security bot is helpful and can give us what we need. And so we're going to go ahead and say public security bot. Remember, all instance variables follow the same name as the class. Not instance variables. All constructors are the same name as the class. What makes them distinct and unique, and we can have more than one, is the parameter list. So we'll say security bots accept security level. And I'm going to write this in a particular fashion because I do want to bring up this keyword soon. And so I'm going to say in security level and Boolean active. And you might already be worrying because you might have said, well, no, your names are not good because, and you might have named them differently on purpose. And so we'll have this discussion right now about what I've done. And I did it on purpose because I want to make some things clear. And thankfully, NetBeans is a very effective IDE and will point out some of these flaws to us almost immediately once we do it. But let's finish up our constructor. Constructors typically take the local parameters and remember the values in the instance variable. So this should be as easy as saying the instance variable security level is equal to the local variable, and then the instance variable active is equal to the local variable active. So I'm just remembering what it is. But you can see immediately the coloring and the yellow lines give us this kind of warning. Notice there are no red lines. This is not a syntactic error that I've made. It is an error, and it is a logical one that is subtle and could cause problems in the future, or pretty quickly if we try to make one of these security bots by using this constructor. And our this keyword is going to happen and be useful in this scenario. And so the problem is we have to remember there are some rules that we know exist. When you declare a variable with a type, you cannot redeclare another variable with the same name. So I cannot say something like private double active. It fails because active already exists. It says, look, variable active is already defined, right, in security bot. But then if that's the case, if the red showed up, how come it doesn't show up here? And again, along with that rule, we discussed the idea that scope is also part of that determination of whether or not a variable is allowed to reuse a name. We saw that, and we said if variables are in different scopes, they can reuse different name or the same name. And so we mentioned that we often write multiple constructors or methods, and we take in the same variable int I, int n, int whatever the idea or whatever value it happens to be, and we can use the same variable names. In this particular scenario, the scope of the instance variables, and this is true for all instance variables, is the entire class. So it's the highest level scope. There it is, right? There they are, active, security level. The scope of this constructor is within the scope of the class. So it is a subscope. And that means it can now have a new set of variables, including ones with the same names. But this is a problem. The idea of subscoped variables having the same names as higher scope or higher level variables is called shadowing. It's acceptable. You're allowed to do it. But the danger is that you may think you're referring to a high-level variable, for example, the instance variable, but you are in fact referring to the local parameter or local variable. And in fact, here it is as proof. Notice how the parameters are colored orange, the instance variables are colored gray and also green when you use them in NetBeans, at least in this color setup, but they both show orange. Orange is equal to orange. And in fact, the yellow even tells us, if I hover over this warning, it says, the assigned value is never used. Assignment to itself. It's like saying 5 is equal to 5. Well, of course, 5 is 5. I mean, that's the kind of the identity that's the identity rule of mathematics. A number is equal to itself. Of course it is. Right? There's no question about it. That's kind of a truism that we just take for granted. And so this is a problem. The shadowing idea is an issue. So shadowing, we'll say shadowing. Sub. Right, so subscoped variables may reuse names, but they cause ambiguity to humans. The computer has no ambiguity, but it's also still a problem because it's making an assumption. The reason that there is no ambiguity to the computer is because it's making an assumption. It's making, unfortunately, a poor assumption, but it's the easiest thing for it to do. And the assumption it makes is, if you're in a scope and you refer to a variable name, it always looks in that scope first. So when we refer to security level, it says, hey, is there a local variable in this scope of the constructor called security level? If there is, that's what we're talking about. And if there's one beyond it, too bad, I don't care. It doesn't know that it exists. It says, oh, well, there's security level, there it is, right? If I were to simply change the name, then immediately the color would change and it says, oh, you must be referring to the instance variable because there is no variable called security level in the local scope, right? It's just a different name now because I got rid of a letter. And so it's important for us to recognize the computer it's not that there isn't an error. It's that there's not a syntactic error. And this is, again, we talked about from the beginning of the year. Semantic, meaningful errors are the harder ones to catch. Computers are not people. They will not spot your intentionality. Unfortunately, we have to be pretty explicit, and this is one of those things that we have to deal with. So, having said that, this keyword is one potential solution to this problem. And so I'm going to go ahead and do this. I'm going to write the note, and then we're going to actually go ahead and fix it. So we can say, I'll say this keyword can be used to specify instance variables. Essentially, what we're saying is when you use the keyword this, we're referring to the class or the object that is of this type. So when we say this, we're talking about a particular security bot. Now, again, we have to kind of use our imaginations. There is no particular security bot in RAM yet because we haven't made a tester, we haven't made a main, we haven't called the constructor. But if we pretend that this code was running, that would imply that there is an object running the code. And that would suggest that there is a set of instance variables that exist that have some content. And when we say this, we're referring to those instance variables. Do we know what values they are? No, but we know that they're instance variable values, whatever they may be. So to clarify between this variable and this variable, we can use the this keyword. And it always refers to the instance variable, not the local variable. And the way we write it is we say this dot. So this is very much like calling a method. We can say this dot security level. And immediately notice now the yellow line is gone and there's a mix and matching of coloring. This is what we meant to say. Take the local variable security level and remember its content in the instance variable security level. And so this dot is what makes it 100% unambiguous to us and to the computer what we're trying to do. And again, this is a matter of style. There's another solution, and I'll use it for the second variable. Instead of saying this dot active, which I could do, I might just do this. And there's no conflict. So this first usage, you may see on the AP exam, but if you write your own code, you're not required to use this dot. It's purely a matter of style and readability. There are some programmers that would argue using this dot on any instance variable is a good thing because it always reminds the reader that you're talking about an instance variable. Now, there's no conflict between the word active and act, but the people that say you should use this dot anyway might say, well, act is now unclear. Active was a good name, it just caused shadowing, so the solution is to get the best of both worlds, to remove shadowing with the this dot keyword, and also keep the name active. And in fact, I'll show one more time that even though there is no ambiguity because the names are different, we can still use the this dot keyword. So some people would argue this is the correct approach, whether or not the variables conflict, saying this dot looks better, it's more consistent, it's more clear, more readable. Now that I leave up to you to decide if you prefer it that way or not. I tend to be of the mindset, same names, use this dot. So there might be conflicts, but I always remember to use this dot, but it's a style choice. If you think calling this thing SL and this thing AT or AC, and then leaving these the way they are and not using this dot, that's okay. There's nothing wrong with it. Right? On the AP exam, you might see code that uses the this dot. So you need to understand what it means and how it's clarifying the problem, but you don't have to necessarily use it yourself. So this is the first instance of this dot notation. Helpful, useful for clarifying a problem that can happen if we're not paying attention to our shadowing, but not something that's absolutely necessary. The only time it's necessary is if you're forced into, for whatever scenario, maybe your boss tells you must use these variable names. Then maybe there's shadowing and then you have to use a this dot. Right here, without this, it would fail and it would be confusing. Here, it's not necessary because the names do not conflict. So that's a matter of choice. So now here's the second, we're going to move into the second scenario where the keyword this is helpful. And this is the one that's not on the AP exam. But I want you to see it because it is useful, it is a style choice, and it definitely can make code smaller in the long run if we do it well. So we're going to make another constructor. This is something we've done before, right? If you don't remember, the word that we use is overloading. Overloading means having multiple constructors or methods that have the same name but different parameter lists, right? So public security bot. And then so this one I'm going to say is, well, what we'll do is we'll take in the security level but just assume that it's active. We don't need a Boolean to be given to us. We'll just assume it's true. So we'll call int security level, and then I won't take in anything else. And so what is the work I'm going to do? I'm going to say this dot security level, and notice I have to use this dot because these two names match. This one and the instance variable match is equal to security level. There it is. And then now, since they didn't give me the Boolean, I'm just going to assign it. I'm just going to say active. And I'm going to be consistent. I don't have to do this, but I'm going to just because I think it looks good. Is true. Did I have to say this dot? No, and I can prove it by getting rid of it. There is no conflict. It's a literal value stored in a variable. There's no need for it, but I think it looks good as a matter of consistency in my code. But you choose what you think is appropriate. And so that's okay, but if you think about it really, we basically did the same work that this did. It literally copies the security level in and then it puts in a value, right? Here we didn't know what it was, true or false, but the point is that it was put in. And so we could leave it like this, or we can use the second view of this keyword. I'm going to put the note here and we'll try it. And this is again a matter of style. We'll say this word can also refer to constructors of the class. Let me put this on 2 lines. There it is, right? So we can also refer to constructors by using the this keyword. And this kind of makes sense because if you think about it, if you're in a class and every constructor has the same name, the name of the class, the this keyword refers to the class name, basically to the class. So when I say this, I mean security bot. Now, what's important, and again, maybe it's not clear, so I'll say it now, wherever you use the this keyword, it refers to the class that it's in. So in this scenario, it refers to the security bot. But if we were in the class bank account and we said this, we would be referring to the bank account. It refers to the class we're in or an object of the type of the class that we're in. So here it's a security bot, but it could be any class really that we're referring to. So let's go ahead and try doing our change. And so I'm going to point out that it's easier to do this in one line, but here it's kind of silly. It's a very small thing. And so I'm going to go ahead and do this. And the way we do this differently, instead of saying dot, we're going to put parentheses, and this is going to tell it I'm looking for a constructor. Right? And so what you have to do is pass in parameters that hopefully match one of the constructors. And so the only other constructor besides this one is one that takes in an integer and a Boolean. So let's go ahead and do that. So I'm going to say security level because that's the number. I don't know what it is, but they gave me a number, so I'll pass that along. And then the true that I wrote. So now I don't need these. I'm going to comment them out temporarily and see that these 2 lines are equivalent to this one line because this one line refers to this constructor. In fact, here's proof. It's silly, and it may seem silly, but it's a really nice proof. When I click on this, notice what it does is it highlights this constructor's name because it recognizes, hey, you're in this class, security bot. You pass in an int because that's an int, and you pass in a Boolean, hey, this matches, bam, you must be referring to this constructor. And that's a really nice feature. And let's do one more to prove this is even more useful because the more you use it, the more effective it becomes. Because here, you could argue in a pretty reasonable way how silly to replace 2 lines with 1 line. That's such a small gain. Why even bother? And maybe it's not as clear to the reader. And I would argue that's not a bad idea. But the more we do it, the better off we become. So we can say public security bot. Let's make another constructor. And this one accepts no parameters. It's a default constructor. So I don't know the security level, and I don't know whether it's active, so we're going to assume those values. And again, I'm going to do it in the 2 lines, and then show, well, we could also use this keyword to use a constructor. We could say this dot security level is equal to 3. Oh, so I'm going to put 3, but in fact, I want to put the minimum. So we'll call it min level. And we'll say this dot active is equal to true. And there it is, right? And so there it is. I could do that, and that's 2 lines, not a problem. And again, these 2 thises are unnecessary because there's no conflicts anywhere, but I put them anyway to be consistent. Or, let me comment them out. We can do this. And now we have 2 choices. Now we have 2 other constructors we can refer to, this one or this one. So why don't we call this one, and just to do it on purpose to see what happens. So here we go. I'm going to say this. And if I click on this, there are actually 2, but right now it says, oh, you must be referring to this one, so let's pass in 3. And now if I click on this one, notice what it does. It highlights this one. It says, ah, you're referring to a constructor. Which constructor exists that takes in a single integer? It's not this one, because this takes an integer and a Boolean. It must be this one. But this one itself calls the other one, so it's kind of like a chain of calls to the method. So again, the idea is that if this was a super complex constructor that had many lines, this one still could be very simple. If it passes in the correct data, those lines would be run somewhere else. It's kind of passing the buck. Just let someone else do the work. Let someone else do the work. But eventually it'll get done. Right, so this is the second usage of the this keyword. It's very powerful. It can really minimize the amount of writing we do for our constructors, but it's not required. You could put the 2 lines. There is no strict, you must do this. No. And in fact, you won't see this on the AP exam. This is a very powerful Java technique, but it's not one that's tested on the exam. You might want to use it yourself to make your burden of writing code smaller, but it's not going. You won't see it tested this way. And so now let's talk about the last one. So we're going to make 2 more methods, and we're going to see that there's yet another way that this keyword. Well, there are 2 other ways that this keyword can be called, but we're going to see them in the same scenario. So let's make this method that determines, and I mentioned up here, that determines if a bot is secure or not. This method will say, hey, give me a bot, a security bot, and I'll tell you whether it's secure or not, and I'll deactivate it if necessary. So we're going to say public because we want someone to use it, and I'm going to say Boolean, and we're going to call it is bot secure. Actually, no, let's do this. Let's call it secure bot. And it accepts 1 parameter. And so the parameter is going to be not a primitive, but it's going to be a security bot. We're saying, look, I need to be given an entire security bot object in order to do what I need to do. And so the input is not an int, not a string, not a double. It is a security bot object. And now this is where the power of classes comes in. We are representing an entire object of security bot in this. So we're going to say bot. So how does this method work? We're going to say if that bot's security level is under the minimum, we must deactivate it and return false. And if it is above the minimum, then we make sure we activate it and then turn it. And then, we don't have to change anything about the minimum, and then we turn it to be active, and we return that it's active. So let's ask that question. If, and now the security bot is called bot. How do I refer to its security level, right? Because we're in the class, we don't have to use an accessor. We could write an accessor called get, security level, and we could write a mutator called set security level, or get active, or set active. But the reality is, because we're in the class itself, I can refer to the instance variable of the bot directly, right? So if the bot dot security level is less than the minimum, so I think it's called min level. And so here's where I'm going to use the this a second time. So I'm going to say this dot min level. Right there it is. So we're saying, look, find the minimum level of this thing. And again, it's a static variable, but it's not an instance variable, but it is static, so we have access to it. So we don't need this at all. And it even tells us you're accessing a static field, which is okay. We don't actually have to use the this dot. But if you want to, you can. And so in this situation, we could also say security bot dot min level. And this is the one that, notice now there's no yellow, because here it says, since it's static, you should use the class name. And remember, static variables can be referred to from their class names. And we are in the class, so we're safe. So either one of these is acceptable. I'm going to leave it this way because this is the static style. This is not. If that's true, then we want to turn the bot to not be active. And then return whether it's active or not. If it was active, then it'll be true. And actually, no, let's do this because we don't know that it was not. So let's turn it on, and we'll say else, and say make bot active, and we'll say else bot.active is true, and then we can return a Boolean that represents what happened, and basically that Boolean is the active value of the bot. So we can say return bot.active. So if it's true, we return true, and if it's false, we return false. It will be set one way or the other, and there's our method, right? And so that's just a method. It uses the class name to call a static variable. That's okay to do. Again, I'll show you. You don't have to use it at all, or you can use the this keyword. Either one, all three of those scenarios work perfectly fine because we have access to the variable in the class. And now here's where the last version of this method is. This is a method to check other robots, other security bots. We might want a method that checks itself. So we could call this method in some fashion, but let's make it easier. Let's just call it like a self-check, right? So let's go ahead and do that. Let's go ahead and make a method, public Boolean self-check, that checks its own value and then returns, and then sets it to active or not, and then returns the value. So self-check. And then we won't need a parameter because it's going to be itself calling it. And now how's this going to work? We don't want to copy this code. We could just copy this code, but that seems redundant. If we're going to copy all the code of a method, we should just use the method. So why don't we use the secure bot method? So again, we have two ways of calling methods that are not static. We can say this dot method name, which is now just like the variables, or we can just use the method name. So I'm going to say this dot secure bot. But now here's the question, and it did it for us, and I kind of ruined the surprise, but the question you have to ask yourself is, who is the input? Which bot are we looking at to check? And the answer is, if we're checking ourselves, we're checking the object that's calling the method, and what variable, or sorry, what keyword refers to the object that exists or is the calling object. The answer is the this keyword. So the this keyword can be passed as a parameter. It is itself an object, and it's an object of the same class type that we're in. So this is a really weird kind of line, but it's powerful. We're saying, hey, call your own method on yourself as your input and then do whatever it does. So in reality, this object is actually the bot that we're referring to in this scenario. But now this method allows us to do it on other bots as well. This is the kind of great thing. We can check ourselves and we can check other ones with the same method. And so the last note we'll say is this keyword can be passed parameter to methods that accept objects of the class type. So again, if there's a method that exists that accepts a security bot object, this can be passed in. Now, again, when you do that, what you're saying is check yourself, but that's okay. You're allowed to do that, and this is a helpful situation here. And so we could keep going with this example, but essentially we've kind of boiled it down to the three scenarios where this is used. For ambiguity's sake, clarifying instance variables versus non-instance variables. For referring to constructors, if we want to kind of minimize our workload by reusing constructors again and again. One constructor calls another constructor. Or passing it as a parameter to a method that accepts objects of this type, of the class type that we're in. And we could also use it to refer to methods of the class. I kind of didn't say it, but essentially, if you can refer to instance variables, you can also refer to non-static methods, and that includes secure bot. So I'm going to end the video here, and if you have questions, please feel free to reach out. But I know this is a complicated subject, but it's powerful. And again, we, for the APA exam, really just kind of be comfortable with the fact that it helps clarify ambiguity, and the third version, which is that it can pass an object as itself into parameters that require objects. And this is kind of a powerful technique. So I'll see you in the next video.